So I am back. If you were here earlier, you may have seen my earlier talk. And this is kind of an extension of that talk, going past like the ideas and philosophy and all the different ways that people are building apps and actually showing how to actually build one of these decentralized apps, and maybe going a little bit deeper into some of the web infrastructure stuff that I touched on earlier. And really the main thing we're going to cover today is kind of what are all the different pieces that are out there and how do you actually get started. And I'm going to live code from scratch a full stack app using a stack of technologies that I'm going to cover in this talk. So to introduce myself again, my name is Nader Dabit, and I'm here to talk about how to build a DAPP. And we're going to be, again, covering a few of the things that I covered earlier, but maybe a little bit more in depth on the actual coding part. And I'm going to touch on some of that stuff for the first 5 minutes, and then we're going to be getting into probably a lot more new stuff. So when the title of the talk is how to build a DAPP. Well, DAPP is just short for decentralized app, and it's just an acronym that you'll hear a lot. And it's essentially kind of building an application and using decentralized technologies to do so. Now, I've been a developer for like 9.5 or 10 years, and coming into this space from AWS, I typically was thinking of what are all the pieces that I need to build an app. And at AWS, that was going to be something like I need Cognito for identity, I need DynamoDB for my database, I might use Lambda for my compute. And that's kind of mentally the way I thought about building an application. You have all these building blocks, you put them together, and you're able to achieve the functionality that you want. Now, with decentralized applications, it's kind of the same thing, but the pieces of infrastructure are much different, and there's also a spectrum of decentralization. So you don't have to kind of build an application that is fully decentralized, or think of it like, when you're building these types of applications, like everything needs to fall into this category. I think what you're seeing is people kind of taking bits and pieces and mixing them together, and they're coming up with interesting new ways to build applications. A lot of people kind of look at this space and they are like, oh, these things don't make a lot of sense for all of the use cases, and they're absolutely right. In fact, most of the applications that we think of today probably would not implement these technologies. Instead, people are coming up with new, interesting types of applications that we've not really seen before, and that's really the things that kind of excite me the most and really what kind of keep me going, I would say, day to day in this new space. So the way I defined Web3 before is a stack of protocols that enable fully decentralized applications, and that's what we're going to be diving into a little bit more today. What are these different protocols and how do they work? And then I also kind of defined Web3 as this combination of all of the different stack that we had in the past, and then we're also adding in smart contracts, which enable these native payments in native state. And what we're going to build out is a really basic application that implements some of this technology. I kind of covered some of this earlier as well, but so the characteristics around a Web3 application have a lot to do really with this set of characteristics: decentralization, self-sovereign identity, native payments. Really, a lot of the stuff that I'm most interested in have to do with this idea of being able to take existing backends and let developers build out different experiences on the front end. So we really kind of go from having these proprietary backends that only certain people can interact with and build upon to really kind of having this idea of an open source backend that anyone can build an application on. So we're going to dive a little bit more into the web infrastructure pieces because I kind of went over these very, very briefly earlier. We're going to go over them a little bit more in depth here. So in a typical database like DynamoDB or a NoSQL or a MySQL database, these databases are optimized for two main types of operations: reading and writing. You can kind of look at different metrics around how many operations per second, how much latency a read takes. When you're doing relational data with MySQL or NoSQL, you kind of have all these benchmarks, and therefore you're going to kind of move and grab the type of database that you would like to use to build the type of application that you would like to be building. And there are different people that really like the NoSQL way of doing things. A lot of people like SQL, relational data, and things like that. But in the blockchain world, it's a lot different because databases are not optimized for reads, they're only optimized for writes. So when you hear about different protocols, they're typically focusing on how many transactions per second can a protocol handle. So when you think of something like Solana, for example, it's been really popular because it can handle, 500,000 or so transactions per second, and therefore it is very scalable compared to other databases that are blockchain databases. But maybe not compared to something like DynamoDB, which is, a lot more scalable than that. But all of the conversations really have to do around how many operations per second can we write and how efficient those operations are. But one of the things that aren't really covered out of the main implementation of a blockchain is how do you read this data? Because this data isn't, again, queryable. It's written over time in the course of days, weeks, months, or years in these blocks. So if you want to get a really, really simple query, you want to read a piece of data at a certain point of time, it's really easy. But if you want to do anything like relational data, or you want to do some type of computed data, you want to do some query, getting a relationship between friends and friends' friends or something like that, it's just not possible. So what people have done in the past is they build out their own indexing servers, which go and get that data, store it in the database, and they build their own API layer on top of it. But this kind of breaks the security mechanisms around decentralization in the first place, and you kind of go from wanting to build a decentralized application to now centralizing your data, and also you're having a single point of failure, which is kind of defeats the whole purpose. So one of the protocols that is out there, and the one that I work with, is called the Graph Protocol. And the Graph Protocol is a protocol that allows developers to participate in a decentralized network in a few different ways. You can be a node operator and index data and serve it up via an API endpoint. You can be a developer that creates these APIs called subgraphs and deploys them to the network and allows other people to use them and consume them. And the network was built not only by the core team, but it was built by people all around the world. So during the development of this protocol, people from South America, from Asia, the United States, all over the world helped build this. And when the protocol finally launched, they shared the ownership of the protocol by distributing tokens, and a lot of people were able to essentially kind of help build this and help own it together and make a living off of it, which to me is pretty interesting. But yeah, this is kind of like one of the pieces. If you want to do now querying for some type of blockchain data, you might use something like the graph. Another piece of the infrastructure is when you're dealing with data that is not on-chain. So only certain types of operations are typically going to be written to a blockchain, because when you have a transaction, you typically have to pay some transaction costs. That's why you see most blockchain applications right now being some type of financial, applications, whether it be, artwork, or whether it be some type of decentralized finance or something like that. But if you do need off-chain data, you can still build in this way. And there are a couple of different options. One of them is a ceramic network. And this is a really interesting way to deal with off-chain data, but also they have a protocol that allows you to deal with self-sovereign identity called IDX that kind of work together, that I'll cover in just a moment. Live streaming. So LivePeer is a live streaming network that allows you as a developer to build live streaming services like Twitch-like experiences. And it is very inexpensive. And it also runs on a decentralized network of nodes. And you can basically spin up your own live streaming platform using LivePeer. IPFS and Arweave are ways to deal with file storage. So in the traditional web space, you might use something like S3, or you might use any version of something like S3, I guess you could say. S3 is definitely one of the main ones people use. But let's say you want to store an image or a video or something like that. IPFS and Arweave are kind of the two main ways you might do that in Web3. IPFS is free, and it typically is not guaranteed to stay there, though. Which is interesting, right? Because if you want to upload something, you want it to be there for a certain amount of time. Now, you can use something like an IPFS pinning service, which guarantees that it stays there for a longer time, but it doesn't guarantee that your file will be there forever. Arweave is interesting because it guarantees pinning forever, and it's not really called pinning, it's just lifelong file storage. So if you want to store a blog post and you want it to be there forever, you can use Arweave. You pay that transaction cost for 1 megabyte of text. It's around 3 or 4 cents, and then it's there forever. So instead of having to pay like a monthly or a yearly hosting fee, you can have an API that stays there essentially forever. And what a lot of people do is they kind of combine these things. So you might use something like a blockchain to anchor an ID for a blog post, and then that ID would be fetched from something like Arweave, and that way you're kind of only storing the least amount of data possible, and you're storing it kind of in the right ways. We're used to the implementations of Git being centralized, even though Git itself is decentralized, but most of the time we're using something like GitHub. Well, Radical is interesting because it is a decentralized Git provider, and you can use it just like you use your own Git that workflow that you've probably used forever in your own day-to-day experience. And then the one thing we're going to be looking into and implementing today as well is sign in with Ethereum or sign in with some type of Ethereum wallet. There's a handful of different wallets that are out there. Solana has a really nice one called Phantom. With Ethereum and similar EVM networks, you can use MetaMask and Rainbow. And these wallets allow you to just be able to sign in without handing over any of your personal information using public key cryptography. So when you create a new wallet, you're given a seed phrase. Using that seed phrase, you're able to derive mathematically a private key. And then using that private key, you're able to derive a public key, and then that public key derives your address. And using all these things together, you can actually have portable identity wherever you go. So let's say you want to have this same identity on your phone or on a new computer. All you need is that seed phrase to re-enable that identity, and from there you're able to interact with all the applications that you're probably used to interacting with just maybe a single click. And we're going to be implementing this in just a moment. And then for identity, if you want to kind of go past really basic authentication, and you do want to implement something like we're used to where we keep like a user profile, you might want to keep your username or even a profile picture, you can use something like IDX. The main difference is IDX only allows you as the user to update the metadata, and you only can update the metadata that you would like to share. So if you don't want to share your phone number, your address, your email address, you don't have to put any of that stuff and store it. You can just store the information that you want made available. So most of the times you would use something like IDX for an e-commerce application where you want to point to a profile that does have some of your personal information, like your shipping address or something like that. So the implementations of Web3 applications are kind of listed here. The ones that interest me the most are definitely the decentralized web infrastructure protocols and the DAOs, I would say. I work at a company that supports a lot of this stuff here, but the main thing we really work on is decentralized web infrastructure protocols. So you could think of the Web3 stack as kind of the old school web stack where we have compute, identity, data, storage, et cetera. And we're now just using these services, but making sure that we try to find decentralized versions of them. And we now have this added smart contract layer, which is something we did not have before. So how do you actually build one of these applications? And this is what we're going to do here now. Well, to get started, the bare minimum, you typically would need something like a front-end framework. You want to choose what type of blockchain you want to build on. Anything that supports a smart contract is something that would kind of fit into this category. You want to choose your client library. So in the front-end world, we might use the combination of something like GraphQL with Apollo, or we might use something like Fetch with some HTTP endpoint. In the Web3 space, we have similar client libraries. Instead of interacting with an HTTP endpoint or a GraphQL endpoint, you're interacting with an RPC endpoint. And you have different options. And we're going to kind of look at the ones that I like the best. And then you have the blockchain itself. So coming from the React and JavaScript world, one of the things that I found really powerful is this idea of learn once and write anywhere. So with React, you learn JavaScript, you learn React, and you can build mobile apps, web apps, desktop apps, watch apps, all kinds of stuff. Well, there is a similar idea in the blockchain world, and it's probably the easiest way to get up and running, and they're hiring these Solidity and EVM developers like hotcakes right now, because if you learn EVM, which is the Ethereum virtual machine, you can write applications for Ethereum and all of the Ethereum layer 2s, and you can write for Avalanche and Celo and all these other blockchains that are kind of like gaining momentum. So you can kind of think of it as the network effect that we've seen with JavaScript kind of happening in the decentralized world, where you can learn this one suite of tools and technologies, and you can build across many different areas. And that's what we're going to be focusing on today, EVM and Ethereum. So again, EVM stands for Ethereum Virtual Machine. A lot of people have taken this Ethereum Virtual Machine and applied it in their own protocols, giving developers the exact same API that they can use. And for the development environment, we might have used something like Next.js as a great abstraction on top of JavaScript and React to give us more things that we can kind of get going with without having to build all this stuff from scratch. Hardhat is really great because it kind of does this for the blockchain world. You start off with a front-end application and you initialize a Hardhat app, and you're given a smart contract, you're given a local Ethereum node, you're given all this stuff that you can start writing code for and kind of get up and running in just really a couple of minutes. So we're kind of starting off with this really basic stack. Our client framework is going to be React or Next.js. Our Ethereum development environment is going to be Hardhat. Our client framework is going to be Ethers.js. The two main client frameworks for interacting with Ethereum and Ethereum virtual machines are Ethers and Web3.js. So either one of those seems to be pretty popular right now. And then for the wallet, we're going to be using MetaMask. So let's go ahead and start off with a live demo. So what I would like to do here is I'm here in a React application. And I'm going to go ahead and open this app in my text editor. And the only thing I've done so far is installed a couple of dependencies. So we have a basic React application, and I installed the dependencies necessary for Hardhat. I haven't initialized a Hardhat environment yet. I just have installed Hardhat and the corresponding dependencies that you can find on their website. So what I'd like to do now is just go ahead and initializing my development environment. So to do that, you can just run npx Hardhat. You don't have to install anything. You can just use npx, and it will go ahead and fetch all of that stuff for you. And it'll walk you through whatever you need to kind of get your project set up. So here I can say create a basic sample project. I can choose the default as the project root. And then I can, of course, just choose yes to get ignore. And then now we've created our development environment. So if I go back to my code base, I can see now I have this contracts folder. The contracts folder holds a smart contract. We have a scripts folder, which holds a script to deploy the contract to the network. And we have a test, which is just a basic test for us to test our code before running the actual code itself. And then we have our Hardhat configuration. And I'm going to delete almost all this code because we don't need any of it. This module.exports really just defines your development environment. So anything that you need set up here, you can kind of put it here. So we're going to start here. And the thing I want to go ahead and set up is our artifacts directory. Now, when we're working with something like GraphQL, we use GraphQL queries, which are query definitions that are typically written, in plain text or something like that and stored somewhere within our project. If we're using a REST API, we can just hit a REST endpoint. But with GraphQL, you need some type of query to kind of define the post that's going across the network. There's something similar with Ethereum and most blockchains. When you're interacting with the network, you typically have something called an ABI, or an application binary interface. And you can actually extract an ABI directly from the contract once you compile that contract. The great thing about Hardhat is that all you need to do is just define the artifacts directory. You can run a single command. It will go ahead and compile all that code for you. And then the other thing that we're setting is the chain ID. Because we're working on local hosts, we're not going to be deploying to a live Ethereum network. We want to tell the network which chain ID our MetaMask wallet is using. And by default, the local host is set to 1337. So this is more like a local configuration that we typically just have. So we've set our configuration. We're now ready to look at our smart contract. So here we have really the hello world of Solidity. And I'll walk through some of this. The main code right here is kind of in the contract greeter. This is very similar to something like TypeScript, though. If you've ever read TypeScript, this should look very familiar. We have two main functions that are happening, and then we have a constructor. In the constructor, we're taking in an argument where we're setting an initial state. the state is greeting, and whatever we pass into that constructor is what gets set as that initial value of greeting, and this value gets set when we deploy the contract. We then have a function to return that greeting. So we just call this function, it returns that value. And then we have a function for updating that greeting. So when we call set greeting, we pass in an argument. That argument changes the state. This is a transaction on chain, meaning we have to actually pay for this transaction using gas in some way. So here we have a really basic hello world, but I think it's a really great getting started point, and we're going to build a front end on top of this. So now that we've checked out our contract, we can now compile our contract if we'd like. So to do that, you can just go to your projects, and I'm going to split my windows up a little bit. I'm going to be here in the top left corner, and I'm going to run npx hardhat compile. And this is going to look in our contracts directory, and it's going to compile our ABIs that we can now use in our front end. So if I go back to my project, and I look in the SRC directory, I see I now have this artifacts directory. And here I have everything I need to not only deploy the contract, but also to interact with it. All right, so we've created our contract, we've compiled it. Now we want to deploy it. So how do we actually deploy an application? Well, a long time ago, we'd upload it to FTP, right? Throw it in a folder, and then it starts working. And then now we're we're much more advanced than that, of course. We might use some of the nice tooling that we have these days, like Amplify or like Vercel or something. But in the Ethereum blockchain world, you're actually writing a transaction to a network whenever you deploy an app. So you're kind of like taking your code and you're writing it to that network, and it's now on chain. So to test that out, we can just run a local network, and it's pretty easy to do that using hardhat. We can actually just run npx hardhat node, and this will create a local Ethereum node, and it will give us 20 different addresses that we can use locally with 10,000 Ethereum each. So we're pretty rich at this point. So here we go with this account number 0. It gives us 2 values. It gives us the account address and the account private key. So using this private key, we can actually import this account into a wallet and start testing it out in our browser. So let's go ahead and do that. So I'm going to go ahead and open Google Chrome. And I'm going to go right here. And I'm going to go to my MetaMask. So this is kind of like the wallet. This is one of my wallets. I also have Phantom. This is for Solana, just to kind of give you an idea of what this stuff looks like. And what I want to do is I want to import one of these accounts. So to do that, I can go to Import Account. I can paste in the private key. And here you see that we now have 9,999.9994 ETH. And I believe this is actually, yeah, this is right, because, let's see here. I'm wondering why this isn't actually 10,000 ETH, because we haven't done anything. So let me try to remove this and then add it back. Either way, we're going to keep going. So let me go ahead and import this again. Yeah, so for some reason we have 9,999. I'm going to figure out why that's not 10,000 in just a moment. But anyway, so we're able to like import these accounts. So if I wanted to import another one, I could do that as well. Let's see what's in that one. Oh, okay, I think I know the problem, yeah. Let me switch these networks. There we go. Okay. Now we have 10,000 ETH, which is right. Okay. So now that we have our local node running, we can actually deploy our application to that node. So let's do that. And to do that, we can run a deployment script, which is also written in JavaScript, which is nice because I'm a JavaScript developer. And we're given a sample script by the hardhat development environment already. And I'm going to delete almost all this code. And we're just going to go, or I would say comments. We're just going to go to these 4 lines of code here. Now, the first line of code is going to go ahead and fetch the location of the ABI. We know where that ABI is because we defined that configuration in our hard hat config. So since it knows to look in the src directory, it can just look for the ABI named greeter. And now it has a reference to that ABI and that contract, actually, both things. And then we're going to go ahead and deploy that by saying, once we have a reference, we're going to call the deploy function on that. We wait for that deployment to complete, and then we log out the address, because we're going to need that address. Because just like in an HTTP endpoint, we need the HTTP URL. In an Ethereum project, you'll need the RPC endpoint along with the address of the contract that you want to interact with. And we're also passing in an argument to deploy, and this is going to be that constructor. So whatever was set in that constructor, we can pass in as an argument here. And this will go ahead and update that local state in our contract. So to deploy this, we can go again back to our terminal, and we can run npx hardhat. And I want to rename this script to something a little bit better than sample script, so let's just call this deploy. And I can say run scripts/deploy, and then I can just set the network to localhost. And what we should see happen is greeter deployed to, and then given our address, and then down here, we should see that we have some stuff that's been logged out. So that means we have created our contract, we've started our local node, we've deployed to that node, and we now want to interact with that contract from our application. So to do that, I will go ahead and run npm start, and we're going to start off with the really, really basic app with not a lot going on. So you might have seen this before if you're a React developer. You just have your hello world. So the first thing we might want to do is, how do we get access to this user? Because authentication is hard, right? We have to kind of let the user sign up. We have to create the service for all that stuff. Well, it's actually pretty easy in Ethereum. All we need to do is get access to this account that is in their wallet. And now our Ethereum has gone down because we paid for that transaction. So we have 0.00004 less than we had before. So to do that, I'm going to go ahead and open src/app.js. And we're going to create a function that allows us to access that user. So I'm going to go ahead and create a function that calls window.ethereum.request. When someone has a wallet installed as an extension in their browser, the browser automatically injects a window.x context. In our case, it'll be window.ethereum. If you're using that Phantom wallet for Solana, it'll be window.solana. And once we can check to see if that window.ethereum is there, we can then request that user to go ahead and give us their address. You can also do null checks here. So you might want to say if window.ethereum, whatever. But since we know that the wallet is there, we can just call await window.ethereum.request, ask for their accounts, and then we'll log out the accounts. This will be an array because you can give access to more than one account, and then we'll just log that out. And then we will create a basic button, and this button will just call that function. So this is a really, really simple authentication flow to get us started. So if I go back, we see that we have this connect wallet button, and I'm going to go ahead and open my terminal as well. And here we should be able to see the user. So if I click connect wallet, we see that this pops up. We're able to choose the address that we'd like to authenticate with. We click connect, and then now we log out the accounts array right here. So we've gotten access to that user. What we now want to do is get access to that user's wallet and send a transaction and interact with our application. So the next thing we might do is we want to allow the user to type and save a message and update that greeter message that we kind of set when we ran the deployment script. So I want to go ahead and import some stuff. We're going to import useState from React, which allows us to deal with local state. We're going to import the Ethers library from Ethers, which allows us to interact with the Ethereum network. We're going to import the ABI that was compiled in the artifacts directory, which is, again, something we're going to need to interact with the network. And then we're going to define the greeter address. And this should be the deployment address of the contract that we deployed a second ago. So if I go here and copy that, I should be able to just use it like this. And you can dynamically do this, of course, if you just use file service or something like that. So we have all this set up. What we want to do next is set some initial state. Let's see here. The state that we're going to be working with is a variable called greeting and a function called setGreetingValue. Maybe we'll set that value to an empty string. And this will allow the user to use a form to kind of update whatever that greeting is going to be. We want to have a function for fetching the greeting. And this is where we are going to interact with the network for the first time. And all of that really is happening in these lines of code here. So the first thing that we're going to do is we're going to get access to that window.ethereum context, and we're going to create what's known as a provider. And the provider allows us to set a variable that we're calling contract that allows us to speak to that contract that's been deployed on the network. And the three arguments that we need are, what is the address for this deployment, what is the provider, and what is the API. So we pass all of those three arguments here, and we can now call all of those functions within our contract directly from this variable. So any read operation we can pretty much do right here. So what we're doing here is we're going to go ahead and just request what the greet value is right now and then log it out here. So this is how we read data. How do we write data? What we're going to do next is create that write transaction. And this is going to be in this set greeting function. We do everything maybe in these lines of code here. The first thing we do is we go ahead and create a provider like we did earlier, but instead of passing in the provider to the contract, we're now creating a variable called signer, because when you need to send a transaction across the network, the user has to authorize that transaction, and they need to sign that from their wallet, and it will cost them some amount of money to do this transaction. So we get a signer, and instead of passing in the provider to the contract, we pass in the signer. And then we wait for this transaction to be approved. So we're going to call set greeting, and the user then gets prompted in their wallet to approve that transaction. Once that is approved, this continues to run. And from there, we just call fetch greeting again to kind of get that updated greeting. So now that all of that is done, we can update our user interface to have a couple of buttons, one for fetching the greeting, one for setting the greeting, and one for allowing the user to type in the updated greeting. So what I should be able to do is save this and go back to my code. And if I click fetch greeting, we see that hello hard hat is there because that's what we passed in when we deployed our contract. So I should now be able to go ahead and set this value here. And now we're prompted to confirm the transaction. And now our data is coming back, hello, all things open. And if I refresh and click fetch greeting, we see that hello, all things open is there. So everything is working as we expected. So with that being said, that's kind of like the most basic full stack hello world you'll see. But I think it is a great getting started point. In fact, a lot of people have kind of taken this demo tutorial just to kind of get their feet wet, and they realize whether or not they even think this is something they're interested in working on. So it's a great getting started point to kind of not spend a ton of time, but still fundamentally understand what this stack feels like and what it looks like. If you want to go a little bit further than this, there's a really great project called Scaffold ETH by Austin Griffith. There are over 200 different repos within this repo, I would say branches within this repo, I guess. And each branch is a separate type of implementation of a Web3 app. So you have everything from finance to gaming to DAOs and really, really cool stuff. And it's all full stack. So you get the front end and the back end and the smart contracts. And it's really just a wealth of information, and it's really interesting just to go through and look at all the stuff that's there. And it's not just built by him, it's built by a lot of people in the community. There's also Anchor. So if you're interested in not looking at Ethereum development, but you want to look at Solana development, which is starting to become a lot more popular because of a bunch of reasons, mainly because it's already running on an environmentally friendly consensus mechanism, and it's not waiting for a merge. But also, the transactions are faster and cheaper on Solana than they are Ethereum. Anchor is a really great version of what Hard Hat kind of is for Solana. My guide, the complete guide to full stack Ethereum development, is something I wrote that's been read a little over 250,000 times now between my blog post and my video. A lot of people seem to like this. It's a little more extensive than what we did in this getting started talk, but the very initial principles are actually done there, like that greeting contract, but then we go a little bit further into how you send monetary transactions within the smart contract, sending money between parties and stuff. So yeah, that's it. I hope you learned something and enjoyed that. I finished a little early, so if you have any questions, I would love to answer your questions, so feel free to come find me anywhere in the conference.